Hello guys, welcome back to Math Zone African Motives. We are still on our mathematics for grade 11, and this is a follow-up exercise from our exponential laws from the exponents that we worked from our previous exercise. We managed to talk about the laws and also some of the questions that basically we are given in our syllabus. So like I said, it's a continuation that we are going to have. Remember, we were on the division of the exponents, and whereby all our questions were on the simplification on how to simplify a given exponent. All right, so I'm just going to put this aside so that you can see our laws that you're going to consider. All right, so let's say in this case, we are given a question to simplify, that is 2 to the exponent of x plus 2 minus 2 to the exponent of x plus 3. All right, everything over. This is 2 to the exponent of x plus 1 minus 2 to the exponent of x plus 2. All right. So if you check from the previous exercises that we had, we talked about this, and I said it is very, very important that you write your numbers in simplest form. But I want us to see the difference that we have this time. This is an expression like we've got a single term here and we've got another term there, because these two, they are being separated by a negative. All right. The previous case, it was a multiplication where we just have to write as prime figures. It was just maybe 2 to the exponent of x plus 2 times 8 to the exponent of x times 9 over 27 to the exponent of x times maybe 4 to the exponent of 2x. It was a multiplication that we had, which is totally different now, because here we are subtracting. There is a subtraction that is between here. So when you're given something of this nature, all right, think of separating your terms. Think of factorization. Okay? Remember, I talked about this in that same previous class, all right? The 2 to the exponent of x that we see here is common, but there is a way of doing that. We are supposed to rewrite this so that you can be able to factor out. Remember what I said, if this you're adding, it means you're simply multiplying 2 to the exponent of x times 2 to the exponent of 2. The basis, if they are the same, remember that you add your exponents. So it's going to be x plus 2 under the same base. All right, minus, we do the same thing, 2 to the exponent of x, which is going to multiply 2 to the exponent of 3. All right, we have got the same situation in the denominator here. There's a 2 to the exponent of x, again 2 to the exponent of x plus 1. So that will be to the exponent of x times 2 to the exponent of 1, minus, we do the same thing on 2 to the exponent of x plus 2, 2 to the exponent of x times 2 to the exponent of a 2. All right, checking that what we see in the numerator being the same to just the 2 to the exponent of x that we see, the 2 to the exponent of x that we see in the numerator that is the same, enables us to factor out that 2 to the exponent of x, which is common. We are now doing our factorization. So this will be 2 to the exponent of x. If we factor out this, what are we going to remain? We are going to remain here with 2 to the exponent of 2 minus, here we are going to remain with 2 to the exponent of 3. So it is the same thing that we are having in the denominator. Again, we've got to the 2 to the exponent of 2, which is the same in this situation here, 2 to the exponent of 2, 2 to the exponent of 2, which is the same. So we can do the factorization just like the previous case. And we remain here with the 2 to the exponent of 1 minus, here we are going to remain with 2 to the exponent of a 2. So these are the questions that you're going to have. And from this part, it simply means we can cancel, because this is a product that we see. So you can cancel the 2 to the exponent of x, and the 2 to the exponent of x are the same. So it's up to you. You can simplify the numerator on its own and get the answer here, or you can just simplify the denominator, everything at once, all right? So if we are to simplify this stage by stage, let's see what you're going to have from the numerator in this case. That's 2 to the exponent of 2 minus 2 to the exponent of a 3. This gives us a negative 4, all right? So that is going to be a negative 4 over, we simplify our denominator, that's 2 to the exponent of 1, which is 2, minus 2 to the exponent of 2, which gives us a negative 2. So this is minus 4 over minus 2, which is a positive 2, all right? Minus 4 divided by negative 2, that's a positive 2. Or we could have simplified this at once. Here at this stage, we could have simplified that at once. Just put a fraction, 2 to the exponent of 2 minus 2 to the exponent of a 3 like this, okay? Over 2 to the exponent of a 1, which is same as a 2, guys. 2 to the exponent of 1 is same as a 2. All right, just write as it is, minus 2 to the exponent of 2 like this. This is going to give us a 2, which is the same answer as the one that we have. So you can simplify this once from this stage to this stage, all right? Or you can simplify the numerator and the denominator separately. All right, so like I said, these are the typical questions that you are going to have on your simplification. They want you to understand this. All right, so still on the same simplification, let's say we are given again, we want the same situation and also a combination of just a multiplication. So this is 2 times 3 to the exponent of x plus 2 to the exponent of x plus 2 plus, in this case, we've got 3 to the exponent of x minus 3, everything over. So I want us to be careful on this question, everything over 5 times 3 to the exponent of x minus 2. So I want us to be very, very careful on this question here. The numerator, in the numerator, you can see that there is that concept again because we are adding. This term is being added to this term. So meaning to say we are supposed to think of your factorization. And in order for you to have the factorization, these must be in simplest form. So we must have each and every number in simplest form. So let's rewrite. That's 2 times 3 to the exponent of x plus 2. We are going to separate this. That's 3 to the exponent of x times 3 to the exponent of 2. All right? Plus, take note, there's a plus that we have, which is separating the 2. Here we do the same thing. I told you guys, whenever, if it's a negative or it's a positive, you separate everything by multiplying 3 to the exponent of x times 3 to the exponent of minus 3 with the sign as it is. Remember, if we add a plus and a minus gives us a minus, so it's going to be x minus 3 as it is before. So since we've got the 3 to the exponent of x, the 3 to the exponent of x, let us also have the same thing even in the denominator. So we're going to expand this as 3 to the exponent of x minus 2 can be written as 3 to the exponent of x times 3 to the exponent of minus 2 like this. Just like 3 to the exponent of x times 3 to the exponent of minus 3. It was 3 to the exponent of x times 3 to the exponent of what? Minus 3. So in the numerator, we have got the same situation that we had previously of having the same term, the 3 to the exponent of x here, and also the same term on this other part because it's separated by a plus. So there are two terms. It's a term and this is a term. So it's an expression. So we can be able to factorize what is common. The 3 to the exponent of x and the 3 to the exponent of x that we have here. So this will be 3 to the exponent of x. What do we remain with? We remain with the 2 times 3 to the exponent of 2. So this will be 2 times 3 to the exponent of 2 plus, take note, there is a sign that is there. That's why we have to factorize. So we are going to add. Here we are going to remain with 3 to the exponent of negative 3. So this is what we have. In the denominator, there is nothing to be factorized. There is no addition or subtraction. It's just a single term. It's a multiplication. So there is no factorization in the denominator. It's just as it is 5 times 3 to the exponent of x times 3 to the exponent of negative 2. If it was a consideration like this that you are adding, you factor out what is common. But here there's nothing that is, it's not an addition. It's a multiplication that we see. So what we can only do is to cancel because it's under a multiplication, and under a multiplication, I told you it's very, very possible. It's very, very possible for you to cancel this 3 to the exponent of x, 3 to the exponent of x. It cancels each other, all right? So you can simplify the numerator this together and see what you're gonna have. Then you simplify the denominator. All right, so let's see from our calculator, what are we going to have from the numerator here? This is, okay, gonna open a bracket, 2 times 3 to the exponent of 2 plus 3 to the exponent of minus 3 like this, 3 to the exponent of minus 3 like this. This gives us 487 over 27, all right? So this is 487 over 27, 487 over 27 like this, which is being divided to whatever that you are going to obtain. So we are going to divide to the answer that you are going to get from this part of 5 times 3 to the exponent of minus 2 in the denominator. That's 3 to the exponent of a negative 2 like this. And this is going to give us 5 over 9. So it's divided to 5 over 9 like this. So remember that in your simplification, whenever you have a division, you remove that by introducing a multiplication. So this is same as 487 over 27 that is being multiplied. The moment you introduce the multiplication, you interchange the second fraction. So this is going to be 9 on top and 5 in the denominator. So it's going to be 9 over 5. So this can be simplified. So here we are simply having 487 over 27 like this. Whatever that we have, we multiply to 9 over 5 like this. So this is going to give us 487 over 15. So this is 487 over 15, or you can write this as a mixed fraction, shift, change this, that's 32 and 7 over 15. So you can even write this as 32 and 7 over 15. That's if you want, you can write it like that, but it's actually not necessary, okay? It's not even necessary for you to do that. Just even as an improper fraction, it's enough, it's sufficient for you to leave your answer like that. Okay, so like I said, these are the questions that you'll be given, and you have to apply your laws wherever they are applicable. All right, let us consider the third question. Let's say again, you're asked to simplify 2 to the exponent of 2x minus 2 to the exponent of x, everything over 2 to the exponent of x minus 1. Okay, a tricky question, very, very tricky question, this one. All right, let's see. I can see that, yes, I've got a 2 to the exponent of x here. I also have, or I can have it here. What does it mean here? Okay, this can be written in 2 ways. Okay, let's get back here. 2 to the exponent of 2x here. A to the exponent of mn like this. It can be written as a to the exponent of mn, or vice versa, a to the exponent of nm. You write it in the way that you want. So if I'm given 2 to the exponent of 2x like this, I can even write this as 2 to the exponent of x times 2 like this. I can even write this as 2 to the exponent of 2 times x in a way that as long I multiply this, x times 2, it is 2x, okay? X times 2 is 2x, not x2, 2x, okay? 2 times x is 2x again. 2 times x is 2x. So meaning to say it's the same thing. But I'm supposed to obtain something of this nature, 2 to the exponent of x. So this is the best way to write it, because I'm already having 2 to the exponent. Instead of me writing 2 to the exponent of 2, then I raise, I'm not seeing the 2 to the exponent of x it's not there. I can't see it. So the best illustration where we can see the 2 to the exponent of x is this one. So I can rewrite this as 2 to the exponent of x being raised to the exponent of 2 minus 2 to the exponent of x, everything over 2 to the exponent of x minus 1. So the question is, what does this part mean if I write it this way? What does it mean? It is the same thing as m to the exponent of 2. What does it mean? It means m times m. There are 2m of them. So this 2 to the this x to the exponent, this 2 to the exponent of x, this one that we see, 2 to the exponent of x squared. It is the same thing as 2 to the exponent of x times 2 to the exponent of x. Is it? Okay, let's prove. If the bases are the same, what do? We add the exponents because we are multiplying. So we're going to add x plus x. What is x plus x? X plus x is 2x. So this is 2 to the exponent of 2x. So it's the same thing. So if it means this, that means there is a 2 to the exponent of x, there is a 2 to the exponent of x. Yes, I can factor it out. I can factor out the 2 to the exponent of x, which is common. If I factor out the 2 to the exponent of x, which is common, what am I going to remain with? Remember, we divide, and we say this and this are the same. So if we divide, there are 2 of them. The 2 to the exponent of x here, there are 2, this one and this one. So if we divide, it means 1 is going to cancel with this one that we factored out. So what are we going to remain with? We are going to remain with the 1 of the 2 to the exponent of x. So here, we are going to remain with the 2 to the exponent of x. So be very careful on how to factorize that. There are 2. 2 to the exponent of x squared is just like you factor out like this. It's just like you are given m squared plus m. Then you factor out m. There are 2 of m's that we have. There are 2 m's that we have here. There are 2 of them. So the moment I factor out, I divide m squared divided to this m. It's going to be m. I'm remaining with 1 m. So it is the same thing. 2 to the exponent of x squared. There are 2 of them. So you remain with 1. Okay? Minus. But on this part, if I factor out 2 to the exponent of x, it is going to cancel with this one. So I'm going to get a 1. It cancels. All right, so everything is over. The denominator as it is 2 to the exponent of x minus 1. So what is going to happen, as you can see, the brackets are the same. This part that we have in this bracket and this part of 2 to the exponent of x minus 1, they are the same. So it means we are going to remain with 2 to the exponent of what? We are going to remain with the 2 to the exponent of x at the end. All right, so that's how they test you. That's how they do test you. They want you to see, to properly analyze your question and understand the application of the laws of your exponents, how to separate, and also your factorization. I want you to see the other question that is a little bit confusing again, a little bit confusing, so that you properly know these questions. Okay, I think that will be the question 4. Or it's a little bit confusing. I want you to see this. Let me write it again. It is on the simplification to simplify. This is question 4. We are given 9 to the exponent of x minus 9 like this. Everything over 3 to the exponent of x minus 3. Okay, this is what we have. It's a subtraction, not a multiplication, meaning to say we are supposed to consider the factorization, which is true. But I want us to see, there is a 9 that I talked about previously. We said 9 can be written as 3, which is 3 to the exponent of what? 3 to the exponent of 2. So it simply means here we're going to have 3 to the exponent of 2 times x. All right? Minus here we have got a 9, which is same as 3 to the exponent of 2 again. Everything over 3 to the exponent of x minus 3. So on this one, you were to wonder to say, okay, is it possible for me to factor out 3 to the exponent of 2 because I have got another 3 to the exponent of 2 in this case? This one is difficult because it means 3 to the exponent of 2. 3 to the exponent of 2 like this is being raised to how many how many times is being raised how many times? We do not know. We do not know how many times. So it is 3 to the exponent of another 3 to, so we do not, x means we do not know how many times. So what can we do? We can really remember what I said about this writing here to say 3 to the exponent of 2 to the exponent of x can be written as 3 to the exponent. We can write x inside and 2 outside like this. It's one and the same thing. Guys, it's one and the same thing. 2 times x, it's what? 2x, okay? Let's multiply. X times 2 is what? It's 2x. So we haven't changed anything. But why writing this way? That is the question. Why do you want us to write this way? I want you to see something. If this is being raised to the exponent of 2, because I can see that this is also raised to the exponent of 2. So there is a difference of 2 squares that is formulated there. Okay, let me write. I want you to see 3 to the exponent of x to the exponent of 2. We just rewrote this as it was. We didn't change anything. It's just a format. But it's the same thing. Minus 3 to the exponent of 2, everything. The denominator, there's nothing that we can do. It's already in simplest form. But I wanted us to see this. All right, this is 2. So where am I getting the 3, the x here? This is 2 here. Sorry, guys. This is 3 to the exponent of 2. All right. I want us to see something. This is raised to the exponent of 2. Also raised to the exponent. This whole part is being raised to the exponent of 2. So I want us to see something from our difference of 2 squares. Remember, our difference of 2 squares, what does it state? It states that if I am given a squared minus b squared, this is equal to a minus b into a plus b, a squared, b squared. So if we check, there are 2 terms that are being raised to the exponent of 2 in this question of ours, which is 3 to the exponent of x. And these 3, we are having these raised to the exponent of 2. So it is the same as this is our a, this is our b. So if this is a squared minus b squared, it gives us a minus b into a plus b. Therefore, we shall have 2 brackets. Our a being 3 to the exponent of x, 3 to the exponent of x. So it's a minus b, a plus b, plus a minus, our b is 3. So it's going to be minus 3. The other part is going to be plus 3. The numbers that are being raised to the exponent of what? To the exponent of 2 are the ones that we are taking as your a and b. In the denominator, there's nothing that we are going to do, just write as it is, 3 to the exponent of x minus 3 like this. But there's something that is happening now. If we consider this properly, we can see that in the denominator, there's something that is common, all right? 3 to the exponent of x minus 3, and the numerator also being common, 3 to the exponent of x minus 3. So these 2 are the same, so they can cancel out. It means this is a 1, this is a 1. So we are left with the 1 in this case. So this is 1 times any number, or this number divided by 1, it is just going to remain as a 1. So that is 1 times 3 to the exponent of x plus 3, which is going to be 3 to the exponent of x plus 3. Remember, if you multiply anything by 1, it remains as it is. So that means if we multiply this 3 to the exponent of x plus 3 by 1, it remains as it is. So these are the typical questions that they will ask you in your simplification. They test you a lot, all right? So let's see, 16 minus 4 to the exponent of x minus 2 to the exponent of x minus 4. Another type of a question that they'll ask you is of this nature. All right. If you consider in our algebra in grade 10, we talked about a condition whereby the variables, the part that consists of variables, should always be positive. All right. X plus 3 into x minus 3, this is what we are used to. Not something like 3 minus x. We are supposed to rewrite expressions of this nature starting with a positive x. So considering that, we can see that here it is limiting us to say there is a 2 to the exponent of x, which is positive. There is a minus 4 to the exponent of x here. This one is a negative. So how can we have this as a positive in the first place? So remember what I said, if you are given, let's take an example of this one, 3 minus x. How can I make this to be a positive? All right, this here is same as minus 3, minus x plus 3, sorry, minus x as it is plus 3. I haven't changed anything. Then for me to make this x to be a positive, I factor out a negative. Negative, negative, it becomes a positive. Positive and a negative, it gives us a negative. So now I have x as a positive. So using this same scenario or same situation, we can see that on this 16 minus 4 to the exponent of x, we can have this as 16 minus 4 to the exponent of x as minus 4 as it is to the exponent of x plus 16. But since I want this to be a positive, what do? I factor out a negative, so that a negative and a negative, they give us positive. So it's now positive 4 to the exponent of x. And positive divided to a negative is a negative, so it's negative 16. Why writing in this format? Already the other one, we are having the part that is having a variable. This one, the 2 to the exponent of x, as a positive. So it's best for you to write these as positive values so that you do not struggle in your simplification. So we're going to have minus the bracket 4 to the exponent of x minus 16 like this, over 2 to the exponent of x minus 4 like this. Okay, this is where we are now. We have made this to be a positive. This is our aim. But yes, we have aimed that, but what is it that we are going to do now? How can we simplify further? Okay, let's consider this. We can see that the 4 can be written as, again, 2 to the exponent of 2, but being raised to the exponent of x. The 16 can be written as minus 4 to the exponent of 2. So if you consider that, we have got that continuum of a difference of 2 squares again. So this means I can rewrite this not as, I can rewrite this as 2 to the exponent of x to the exponent of 2, not this way. In this one, instead of me writing this way, I'm going to write it this way, in a way that I'm having the exponent of 2 for the difference of 2 squares, for the difference of 2 squares. So this here is the same as, we are going to have negative bracket 2 to the exponent of x, all right? To the exponent of 2. This represents 4 to the exponent of x, okay? Minus 16, which is 4 squared. So this is going to be 4 squared like this. Everything over 2 to the exponent of x. So 4 is already in simplest form because already there's a 4 squared. So this 4, we are just going to leave it like that as a minus 4. Just leave it like that because already here there is a 4. All right, as long it is being raised to the exponent of 2, it's fine. Leave it like that, okay? Do not worry about that, okay? Now, we have our difference of 2 squares. Remember our format, a squared minus b squared. I said it gives us a minus b into a plus b. So that's what we have exactly here for the numbers that are being raised to the exponent of 2, or the terms that are being raised to the exponent of 2. We've got 2 to the exponent of x being raised to the exponent of 2. We also have this 4 here being raised to the exponent of 2, just like a squared minus b squared, and we are subtracting. So that's a difference of 2 squares. So what does it mean? We are going to have a minus already that is out of the bracket, this one. So this is a minus. Then we factorize our difference of 2 squares, where we are going to get 2 brackets, a and b. This is our a, the one that is being raised to the exponent of 2, and this is our b. So a, which is 2 to the exponent of x, minus b, which is a 4. Another bracket is going to add a plus b, that is 2 to the exponent of x plus a 4. Take note, difference of 2 squares, a minus b, a plus b. This is our a, the whole of this part that is being raised to the exponent of 2 is your a. B, the other part, minus b squared. So we've got a minus b, a plus b. Everything over the denominator. The denominator, like I said before, it's already in simplest form. So there's nothing that you're going to do, just write as it is, 2 to the exponent of x minus 4. But what is happening is that we can see that the numerator and the denominator, there is something common. The 2 to the exponent of x minus 4 and the 2 to the exponent of x minus 4 can cancel. So this is just a 1. So simply, we are left with a negative in this case. So this is going to be negative 1 over 1, which is negative 1. So that's negative into 2 to the exponent of x plus a 4. Or you can multiply by a negative, negative times 2 to the exponent of x. That's negative 2 to the exponent of x, negative times a 4, which is going to give us a negative 4. So you can even write your answer in simplest form like that. This is how we can have our questions. So that was a follow-up exercise, like I said, from the previous exercise that we had. we had managed to work on more questions from that exercise, from that introduction. So make sure that you do so by answering question papers, as much questions as you can. We shall be answering, or we shall be having question papers as a follow-up again for you guys, so that you properly understand this topic. How do they ask these questions, and how are you supposed to attempt these typical questions? But for now, that's it. Till we meet again.